Hi everybody, and thank you for tuning into our viaTalks this week. We have Katie doing 5 common security mistakes in mobile app development. If you would like to follow along on Twitter, we have the hashtag viaTalks, that's viaTalks with an S, and we also have the handle @viaforensics. So you can send us any questions you have there, or you can comment them in the sidebar to your right. Today we have, as I said, Katie, who is our presenter. She is the Director of Mobile Services here at viaForensics, and she's been here for 5 years since we started. She is also the co-author of the title iPhone and iOS Forensics. She holds the CCE Forensic Certification and currently leads viaForensics mobile application and device security assessments. So welcome, Katie. Thank you so much, and go ahead.
Thanks, Lene. Thank you, everyone, for joining. The goal of today's viaTalk is to cover some of the most common vulnerabilities that are found in mobile apps. But before we do that, I wanted to talk briefly about some of the techniques used to uncover these vulnerabilities. Essentially, what do we care about, or what do we look for when we analyze an app? If you've attended any of our prior viaTalks, these test domains on the screen right here might look familiar to you. These are the main areas that we analyze both as part of our AppSecure service as well as the test domains that are built into our viaLab product, which was talked about a couple weeks back. The first area is forensic analysis, and here what we're doing is extracting data from the device to see if user or app data is stored in the private app folder, log files, or device memory. We're looking for high-risk issues, which may include things like sensitive values being stored in plain text in really any of these locations. The second area is network and web testing, and the goal here is to intercept the communication between the app and the server and really ensure that that data is transmitted in a secure manner. We check for susceptibility to man-in-the-middle attacks and SSL proxy interception, both of which we're going to be covering later in this presentation. The final area is code analysis, and here we're checking for things such as if debug is enabled, if the app has implemented code obfuscation, or if the developers are doing any type of tamper detection to determine whether or not the app has been modified. So using these test domains, we actually did some analysis a while back on 100 of the most popular apps in the App Store and Google Play, and we analyzed them for common security flaws. We wanted to know if these apps that we were using on our own personal devices were securing our personal app data. So this chart shows the high-level results of what we found. In general, most applications were caching the username, which may or may not have been a decision by the user to avoid having to re-enter their information every time they wanted to sign in. But what we were also seeing is that we were able to recover the password for about 25% of these apps, and about 15 to 20% were failing man-in-the-middle attacks, allowing us to intercept credentials or app data. These percentages were much higher than we were expecting, and so since that study, we've done several webinars, blogs, and white papers to help increase the knowledge in mobile app security. And so moving on to our top 5, these were determined after 4 or 5 years of performing app security assessments on various types of apps, including financial, healthcare, and retail. The 5 that we're going to discuss today are the most common issues that we come across. And really, from 2010, when we first started doing this testing, until now, these really haven't changed a whole lot. And so the first one on our list is insecure storage of credentials. As many of you may know, it's a common practice to store usernames and passwords so people don't have to re-enter them. However, there are different ways to go about that. In our testing, we've come across many apps that store user credentials in clear text in a plist or an XML file sitting on the device. And this is, of course, the worst case scenario, as there's very little time and effort needed to recover this information. Other common areas that we find credentials, specifically in iOS, is the keychain. If leveraged properly, this is a much more secure location as it's protected by the device passcode and iOS-based encryption, but there are still ways to decrypt the keychain and gain access to the data within. Other areas that we could potentially find credentials fall under the OWASP Mobile Top 10 category of unintended data leakage, which can include system log files, application backgrounding, snapshots, as well as other areas. The second one on our list here is insecure storage of app data in general. So not just the credentials, but anything contained within the app. And so similar to storing credentials, we also see app data getting stored locally on the device. And in many cases, it's consolidated into one convenient area, typically a SQLite database. But app data storage can also occur in XML files or device logs and app snapshots that we mentioned in the previous slide. Plain text storage in SQLite databases is actually fairly common, and we've even seen financial apps storing all accounts, transaction details, and balances in that one centralized location. To prevent access to this data, it's always recommended to avoid storing or caching in easy-to-access locations, such as an SD card, for example. On Android, an SD card is a location that all apps have access to, even potential malicious apps, so that would not be a secure location to store important information. If storage is needed, we recommend encrypting this data using a randomly generated master key, which is based on the user's passcode. So this will prevent data from being easily recovered should an attacker extract that master key from the device. The third in our top 5 on the list is a simple one. It's logging remains enabled. And so debug logs are generally designed to be used to detect and correct flaws in an application during the development process. But these logs can also leak sensitive information, and in some cases, we've seen logging left enabled in production builds. Depending on the nature of the application and the level of debug enabled, it's possible to recover highly sensitive data here, and that's something that's easy to recover and can also be an easy fix. Log files on mobile devices can be recovered using Logcat on Android or through syslog on iOS, and so it's important to ensure that sensitive user or app data is not being logged in a production build. So the next one on our list, number 4 here, is certificate validation and pinning. While we did combine both of these into one slide here, they really are 2 different levels of risk. So I'm going to provide a little bit more detail on that here. As mentioned in that chart previously, about 15% of those mobile apps that we tested in the study were not properly validating SSL certificates, which was leaving them susceptible to man-in-the-middle attacks. When an app uses HTTPS, it's also important to perform certificate validation to prevent this type of attack. What man-in-the-middle does is it allows an attacker to sit between the app and the server that it's trying to communicate with, allowing that man-in-the-middle to intercept all traffic. And so if an app is not doing proper certificate validation, all data being sent to the server can be viewed. So to make this type of attack more difficult, the SSL cert should be fully validated and signed by a trusted certificate authority. With certificate validation, the app is simply validating that the cert was signed by a trusted CA. But since a mobile app knows exactly where it will be connecting, developers can even go one step further and specify which certificate it will accept. So validating that the certificate presented to the app is actually the correct certificate can prevent even advanced attempts at intercepting traffic, and this is called certificate pinning. The final vulnerability that we have here relates to code protection. Reverse engineering apps can provide valuable insight into how your app works, and by making them more complex internally, an attacker is at a disadvantage to seeing the clear operation of the app, which could potentially reduce the number of attack vectors. We have a few recommendations in relation to code protection that can help increase the difficulty of analysis by malicious users, and some of those are listed here. The first is obfuscating source code. And what this does is rewrites the names of packages, classes, and methods with nondescript names, which makes it much more difficult to understand the code. It's also recommended to prevent debuggers from attaching to a process while the app is in use. And this can be accomplished through a system call on iOS or setting debuggable to false on Android, for example. A final recommendation on the slide here is to implement some form of tamper detection within the app. By checking the app's signature, a developer can prevent a modified application from running on a user's device. That quickly wraps up at a high level the top 5 common vulnerabilities. We tried to also incorporate some recommended best practices within the presentation, so not only identifying the vulnerabilities, but also what can you do to remediate those vulnerabilities. I realize it was done at a very high level. However, if you're more interested in learning about how to remediate or how to securely develop an app, we do have some information available on our site called our 42+ Mobile Secure Development Best Practices. And these have much more details on some of the recommendations I provided, plus about 45 more that were not covered in the presentation here. So this slide kind of sums up what you can do to better secure your apps, whether you're a developer or a security analyst. Really, education is the baseline to it. So as I mentioned, those best practices are a great start for developers. We also will be releasing at some point this week the viaLab Community Edition, which is our mobile security assessment product that accelerates assessments to identify vulnerabilities in mobile apps. Our full-fledged version does a really thorough security analysis, but if you're interested in just a quick start, you can run your app through the viaLab Community Edition and do some basic forensic and network analysis that we discussed earlier in the presentation.
Thanks, Katie. That was really interesting. We actually have a bunch of questions already lined up for this. So I just wanted to remind everybody that you can follow us on Twitter at viaForensics and ask any questions that you have there, or you can keep them coming into the sidebar here to your right. And also, if you're interested in seeing any past answers or even from older viaTalks, you can search the hashtag viaTalks with an S on the end on Twitter, and you'll be able to see our entire history of the 2014 viaTalks series. So with that, I will pass it to Katie and she can get started on some questions.
Okay, great. And just so you guys know, we have questions coming from various areas through Twitter, through the webinar, and through email as well. So I'm going to try my best to cover as much as we possibly can. For those that we cannot get to in this live webinar, we will we'll add the answers to those questions before we publish the recording on our site. And so the first question is, does a mobile device have to be jailbroken or rooted to perform a security assessment on an app? And the short answer is, to complete a thorough analysis, it does. There are absolutely some tests that can be performed without privileged access, such as testing for certificate validation or for forensic analysis of some of the application within the private app folder. However, without root or jailbreak access, you won't have access to all of the files stored in that private app folder. You also won't be able to perform some of the more advanced tests like bypassing tamper detection or performing dynamic code analysis. The second question we have that came in here is, where is the most secure place to store sensitive values on iOS? So I know I mentioned that we do have the ability to decrypt and gain access to the keychain on iOS, but this really still is the best place to store sensitive information. It's not possible for a malicious app to access other apps' keychain items unless the device is jailbroken. And on top of that, the data protection classes that are used also play an important role in when those values can be accessed. So it's recommended to use the most secure protection class available for the particular application that you're developing. And I see one more so far. Do you have any recommended resources or tools that I can use to test my app? We sort of covered these in that last slide there, but the first one from a development perspective, or really from a security analyst perspective, is our 42+ best practices that is available on our site. It's really a good starting point or a good checklist to go through to make sure you're covering the basics. And from there, the most important thing to do is really to test your app. Whether you're doing it internally or a third party is doing it, you can start off with that viaLab Community Edition that I mentioned, which provides limited testing, but it's definitely a good starting point. Those are two resources that I would suggest. And so far, I think that's all we saw come in. Again, if we see any others submitted after we're done here, we can go ahead and add those to the recording.
Thank you, everybody, for tuning in. I just wanted to remind you all that we have another viaTalks next week at 1 p.m., same time, same day, and it will be Tom Anderson talking about deleted data recovery with viaExtract. So you can sign up for that at the link on this thing, or we will send you out a link in the video description on YouTube. If you want to find our videos on YouTube, that's youtube.com/viaprotect, and we will have a full recording of this webinar available there, as well as previous webinars, and hopefully some snippets from the best questions from this video. So if you have any further questions, please don't hesitate to send them in. We will be happy to answer them before we post it. And otherwise, thank you so much for tuning in, and have a great day.